let's look at another application of determinants. This one's called Cramer's rule. So if you follow the formula for the inverse given by the determinant adjugate formula, you actually end up with Cramer's rule as stated here. So here's the full statement. Let's say that we know a matrix A is invertible, and we're studying the system AX equals B. It turns out that there are formulas for each of the individual coordinates of the solution vector X. So what this says is that X turns out to equal 1 divided by the determinant of A, multiplied by the vector of determinants of A1, A2 up to AN, where here A sub I is meant to denote the matrix obtained by replacing the ith column of A with the vector B. So here we have an explicit formula for all of the coordinates of the solution vector X to AX equals B under the condition that A is invertible here. And what this requires us to do is calculate lots of determinants. So let's say we're studying this 3 by 3 system here. This is the system AX equals B, where A is this 3 by 3 coefficient matrix. X is the vector of variables, X, Y, Z. And B is what we would get in the augmented column if we were to represent the system as an augmented matrix. -2, -88, -9. So let's say that we wanted to use Cramer's rule to solve the system. Well, what data would we need? We would have to calculate lots of determinants. The first thing we will need is the determinant of A, which I did, and I happened to find that it was -9. Now, once I know that the determinant of A is -9 here, I immediately know that A is non-singular and that there is an inverse because this determinant is not 0. But to use Cramer's rule, I need 3 more determinants. I need to take the matrix A and swap out its first column with the vector B in question, and then take the determinant again. Here, when I take the determinant, I end up with 351. Then I need to do the same process, but instead of replacing the first column with B, I need to replace the second column with B and take a determinant. And when I took that determinant, I got 372. Then we need to do the same thing with the third column of A. So we start with A and we replace the third column with the vector B. And then we take another determinant. And here, when I did that, I got the number -60. So now Cramer's rule tells me what the solution to the system is. It's 1 divided by the determinant of A, so that's -1/9, multiplied by the vector of determinants that we just calculated. So we get 351, 372, -60 in that vector. So the first coordinate of the solution vector to this system X would be 351 divided by -9. The second coordinate would be 372 divided by -9. And the third coordinate would be -60 divided by -9. So here we've successfully used Cramer's rule to solve the system. We had to do a bunch of determinants, but given that we were comfortable doing those determinants, we do indeed get the solution to the system.